Welcome to another lesson on our past paper questions. Here in question 2, part C, May 2011, CSEC exam past papers. Here we have part C. They're asking us to factorize completely. Now we have x times y cubed plus x squared times y. Now when factorizing, one of the most important things to look for is what is common to both terms. Okay, now if you look carefully, I have a x here and a y, and when I look on the other side of my plus sign, I have a x and a y. So obviously x is common, and x and y is common to both terms rather. Now if you look carefully, what I'm going to do, I'm going to choose the x with the lowest power. Alright, so when asked to factorize, I'm going to choose after I've figured out what is common to both terms, meaning what is here, what is over here, and the same thing must be over there too. That's what I mean by what is common. I'm going to choose the letters with the lowest power, alright, or the numbers if we had numbers. Here we have x to the 1, here we have x to the 2, so obviously x to the 1 would be the power that I'm choosing, this x. Now I have y to the 3 and I have y to the 1, so obviously y to the 1 is the lowest power. So what I'm going to say now, I've taken out my factor, I've found my factor, so I'm going to divide through. So I'm going to say x into x, x will cancel x, y into y, y cube, y will cancel one of the y's here, leaving me with a y square. Okay, and then I'm going to say x into x square will leave me with a x, all right, and y will cancel y. So here I have my answer. Okay, and it's that easy when asked to factorize. So that would be my answer for part 1 of question 2, part C. We have xy times y squared plus x in bracket. Okay, and if you should multiply it out, you would get back the original problem that you were given there, and you could try that on your own. Okay, now here we have another part to factorize, so let's just pull this up a bit so we can get a little bit more space. All right, so again, when asked to factorize, what you're going to do, you're going to take out what is common to both terms. So here I am comparing these two terms, and if you're not sure about factorization, we have a playlist on factorization. All right, so here when I look at these two terms, I'm just taking out what is common. I notice there's a 2 there, so I'm going to take out that, and when I look again, I notice that there is an h. So 2 is here and 2 is over there, h is here, h is there. So now I found what is common, so I'm going to open my bracket and I'm going to say 2h. 2 will cancel 2 and h will cancel h, so I'm left with an m. Okay, minus, if you notice, 2 here will cancel the 2, h will cancel h, so I'm left with an n. Okay, now I'm going to, any sign that is here, that's what I'm going to take down here. So let me just change the color. So this sign here, my negative sign, I'm going to carry it down there, and I'm going to again look what is common. I notice a 3 is common, so I'm going to put my 3 there. Let me just change the color a bit. So I'm going to put my 3 right there, and then I'm looking again to see what else is common, and I notice that there's a k there. Okay, so negative 3k is common to both terms, so I can now go ahead, open bracket, 3 will cancel 3 here, k will cancel k, leaving me with an m, and then I have a negative here going into a positive there, so obviously that will give me a negative, and I have 3 will cancel 3 again, k will cancel k, and I'm left with an n. Now the important thing to note when factorizing is that when you reach here, the same thing that is inside this bracket, same thing that is inside this bracket must be inside that bracket. Okay, now after we have achieved this, okay, let me just put my imply sign. I can say this implies that, and I'm going to rewrite what's inside one of my brackets since I have two same thing there. So I'm going to say open bracket m minus n. I am just rewriting what's inside one of these brackets, and then I'm going to open another bracket and I'm going to group what's on the outside. So I have a 2h there, 2h, and then I have a minus 3k. okay, and those are my factors. That's my answer, guys. Okay, it's that easy. Now that is that. Let's move on to part D in question 2. Here they gave us the table below shows corresponding values of the variables x and y, where y varies directly as x. So here we have a direct relationship. They said it. They said here that y varies directly, and this is the word. This is a crucial word here. Directly. Y varies directly as x. Now they're asked that here's the table when x is 2, y is 12, when x is 5, y is a, and when x is b, y is 12. Now they're asking us to calculate values of a and b, and this is another 3 marks, easy 3 marks. So let's look at it. All right, when given two variables, and especially when they're stated that it's stated rather that they have a direct relationship, I can say then y, this is as a general formula. Y, they stated y varies directly as x. So what this is saying, y is equal to x times some constant k. Really, this is pretty straightforward. What this is saying is that if y increases, x also increases. But x, the only way x can increase if it's being multiplied by a constant k. Okay, that's all it is saying. So when two things has a direct relationship, or two variables has a direct relationship, it's in this form. This is just a general form that it is in. Now, the first thing that we should note is that if we want to solve for a and b in this question, let me just pull this up a bit so that we can have a little bit more space. Here, if we want to solve for a and b inside this, in this question rather, then I am taking the general form and I'm going to just simply say I have to solve for my constant k first. I don't know what is k. I have two values for x here. I have a value for x rather and a value for y. So I would first have to find my value for k before I can find a and b. And it's pretty easy. So what I'm going to say here now, in the general form, in solving for k, I'm going to say when y is 12, I'm just substituting here, y is 12, x must be equal to 2, and that's being multiplied by a constant k. So let's solve for k. If you notice, 2 is multiplying k, so I must do the opposite of multiplication to solve, which is to divide through by 2. So 2 will cancel 2, and 2 into itself once, 2 into 12 goes 6 times. So therefore k is equal to 6. Okay, so now I've found the value for k, so I can go ahead now and find the values for a and b. So this is the first thing we must do. All right, this is the first thing we must do. We have to find the value for k when dealing with a direct or inverse relationship. All right, now part 2, we can just quickly go ahead and solve for a first, since they stated it here. So I can say, and I'm going back to my general form, which is y is equal to x k. Okay, but here if I'm solving for a, then I have to substitute a for y now because it's in the y row. So I would say a is equal to, and when I look above, I must find the corresponding x value. X is now 5. X is now 5 times k, and I found k here to be 6. Alright, so really a is equal to 5 times 6, which is 30. So I can say therefore the value of a is equal to 30. Let's just pull this over a bit to get a little bit more space, okay, to work with. So I can hence go ahead now and solve for my value b, which is should be pretty straightforward. As you should have note now, I'm just simply going back to my general form, which is y is equal to xk, and then I'm just looking at my table and substituting. Now here y is 48, so I'm just going to substitute y for 48 in the general form, and this is equal to x. X is now b, so I can say b times some constant k, which I found here to be 6. Okay, and we should know that this is the same. 48 is equal to b times 6 is the same as 48 is equal to 6b. We should have gotten this now. So 6 is multiplying b, so to solve for b I must divide through by 6. Okay, so 6 into itself goes once, 6 cancel that, 6 here goes into itself once, 6 into 48 goes 8 times 8 6 is 48. All right, so therefore my b is equal to 8. Okay, so there we go, we have found our values for a and b. All right, bye bye.